Hello, in this short lecture I will give a proof of the Pythagorean theorem. Pythagorean theorem is that in a right triangle the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. Or in this triangle, the square of the hypotenuse is c squared equals to the sum of the squares of the perpendiculars, that is a squared plus b squared equals to c squared. Okay, so that is what we need to prove. Let's assume that the right-angled triangle is ABC. This is our right-angled triangle in the right side of the drawing. Now, actually, we will do a copy of this right-angled triangle here, and actually we will build along the length of side A. We will build on the same line. We will build the side B. We will draw side B here, and raise a perpendicular whose length is the length of side A. Okay, so we actually, on the same line of side A, draw side B of that triangle, and then raise perpendicular that its length is A. Okay, now we have two triangles ABC at the right and triangle ABC at the left, and two sides of those triangles are equal to each other, because side A equals to side A and side B in this triangle equals to side B in this triangle, because that's how we built it. Okay, we have two sides that equals in these two triangles, and also the angles between these two sides are equal to each other. this angle is equal to this angle, and from the beginning the angle of 90 degrees in this right angle triangle was this angle is 90 degrees, and actually because we raised a perpendicular in length A, so that angle is also 90 degrees. So therefore, triangle ABC in the right side coincides with the triangle ABC on the left side according to the rule side angle side. That is to say, if two triangles that have two sides that are equal to each other, and also the angle between these sides is equal to each other in both triangles, so the triangles are congruent. Okay, A equals to A, B equals to B, and this angle between A and B is 90 degrees, and this angle between A and B is also 90 degrees. Therefore, this ABC triangle coincides with this ABC triangle. They congruent, and since the third side of the triangle ABC on the right is C, the third side of this triangle is C, then because of the overlap of the two triangles, then the third side of the left triangle is also C. Because they overlap, they coincide, so it must be also C. Okay, let's mark the angle between sides A and C with alpha. The angle between side A and C, we'll call it alpha. Here also the angle between side A and side C, we'll call it alpha. As we know, the sum of the angles in a triangle is equal to 180 degrees. Therefore, the angle between sides A and C will be if we call this angle X, we want to find, we don't know how much degrees this angle is, so we will call it X. We know that X plus 90 plus alpha must be 180 degrees, because the sum of the three angles in any triangle is 180 degrees. Okay? So X plus 90 plus alpha equals to 180 degrees. Therefore, EX is equal to 90 minus alpha. Okay. X plus 90 plus alpha equals to 180 degrees. We will subtract 90 from both sides of the equation, and then we will move alpha, we will subtract alpha from both sides of the equation. Then we will get that X is equals to 90 minus alpha. Okay. And since the sum of the angles on a straight line is 180 degrees, then the angle between the sides C and C, this angle in the middle triangle will be, if we want to know how many degrees is this angle, so we will call to this angle Y. This angle is alpha, and this angle is X equals to 90 minus alpha. And we know that the sum of the angles in a line, in a straight line, is 180 degrees. So alpha plus Y plus X that equals to 90 minus alpha is equal to 180. Okay, as you can see here, alpha plus Y plus 90 minus alpha equals to 180. So alpha minus alpha is 0, and then we will subtract 90 degrees from both sides of the equation. Then we will get that Y equals to 90 degrees. Okay, Y equals to 90 degrees. So this angle is 90 degrees. On the other end, the area of a trapeze is equal to the sum of the parallel sides. The sum of the parallel sides, this A and B are parallel, so it is A plus B multiply by the height of the trapeze. The height of the trapeze is A plus B, so it is A plus B times A plus B, or A plus B squared, divide by 2. So in total we get this mathematical notation. The area of the trapeze is A plus B times A plus B divided by 2. That is the sum of the sides A and B divided by the height of the trapeze, that is A plus B divided by 2, or it is A plus B squared divided by 2. So this is one way to calculate the area of this trapeze. On the other hand, the area of the trapeze is equal to the sum of three triangles. This triangle plus this triangle plus this triangle, yes? And the area of this triangle is A times B divided by 2. The area of this triangle is C times C divided by 2. And the area of this triangle is A times B divided by 2. So the sum of the areas of the three triangles is A plus A times B, A multiplied by B divided by 2 plus A multiplied by D divided by 2 plus C squared divided by 2. So we actually calculated the area of the trapeze in two different ways, and by comparing the two expressions we got we get Pythagorean theorem. Okay, so actually this is the first way to calculate the area of the trapeze. A plus B squared divided by 2. It equals to the sum of the three triangles, that is A plus B divided by 2 plus A plus B divided by 2 equals to AB, plus the area of the middle triangle, that is C squared divided by 2. Then actually we will multiply both sides of that equation by 2. We will get A plus B squared equals to A times B times 2 is 2AB, and C squared divided by 2 multiplied by 2 is C squared. Okay, and then A plus B squared is equals to A plus B times A plus B, and it equals to 2AB plus C squared, and actually A multiplied by A is A squared, and B times A is BA, and B times B is B squared. Actually it is A squared plus B squared plus 2AB. Then we will deduct 2AB from both sides of the equation, and we will get that A squared plus B squared equals to C squared, and this is actually Pythagorean's theorem, and in this way we actually prove the Pythagoras theorem that says that the square of the hypotenuse is equal to the sum of the squares of the perpendiculars, or a squared plus b squared equals to c squared. Okay, thank you very much.